And I think we're ready to start. Hello, and welcome to the RX Hope Table Talk session number 11, SCN2A related autism and mobile research, how we bring the participation to you. This session is being recorded. My name is Emily Park, and I'm a board member for the Families SCN2A Foundation. We are very excited to be bringing this virtual educational experience to our global community. During these sessions, the families and caregivers of the patients with SCN2A related disorders will be referred to as the experts, and the presenters will be the professionals. The goal of the virtual table talks is to allow experts unprecedented access to professional researchers and clinicians working diligently to find a cure for our children. This is meant to be a casual environment, and your questions and comments are encouraged as we are all here to learn from one another. To keep things running smoothly, please keep your audio on mute and use the reactions button to raise your hand if you would like to talk. Alternatively, you can send questions through the chat. If you haven't already, please introduce yourself and your SCN2A child in the chat, perhaps their name, age, how SCN2A presents, for example, as autism, epilepsy, both, or something else, and maybe where you live. I now have the pleasure to hand this over to a longtime scientific medical advisor for the foundation, Dr. Caitlin Hudak.
Hi, everyone. It's good to be here. I'm excited to chat with you today. I mentioned earlier, feel free to interrupt me in the middle. I'm going to go through just some slides to kind of show what we do and what we're literally launching our study this week. So we're very, very excited to be able to be with you today. So hopefully everyone can see slides now. Great. I'm going to just make the faces smaller. So I won't necessarily see you, but feel free to chime in and unmute yourself if you have a question. So I'm a professor at the University of Alabama currently, and my lab, we call ourselves the BRAD lab, or the Brain Research Across Development Lab, because we spend a lot of time thinking about how the brain changes and how that might relate to features and functioning. And so we do a lot of work with kiddos with neurodevelopmental disorders like autism and intellectual disability. And I've been involved pretty intensely with the Families SCN2A Foundation for a couple of years now. We are excited to have the last family meeting in Seattle where we did some mobile testing actually, and some in-person testing. So my objective today is to talk a little bit more about what that looks like when we're doing this mobile research and what those opportunities might be, particularly for anyone who might be on the fence or is just kind of curious about it. And just for the amount of time I have, I won't go too deep into the autism profile in SCN2A, but that's the area that I'm coming from to you from. So I work mostly with kids with autism, and am actually trying to increase the amount of kids that I know that have more seizure phenotypes. Just a brief land acknowledgement. So the University of Alabama is located here with this little A, which is the land of the Muskogee Creek. Okay, so the work that we do in our lab is meant to understand our kiddos from kind of all of these different levels. So we first got to know about SCN2A because of about 40 years of genetic discovery in autism. So what would happen is that individuals with autism would come in, and with this clinical diagnosis, we would look at the blood or saliva to understand what genes might be associated. And so that's how we first got to know about SCN2A as being an important gene and having a role potentially in autism. But in the past, I guess 5 or 6 years, we've really started to flip this on its head. So instead of only seeing kids with autism, we're starting with kids that have a known genetic disruption and working from there to kind of look at these other levels. So knowing that the gene isn't working the way that we think it's going to work, but then really kind of digging into all of these different pieces. And the reason why this is so important is that when we think about autism or epilepsy, we often see kind of a mixture. We call this heterogeneity. So different kids are going to have different presentation types. And some of them we are expecting they're going to have some sort of kind of combination. So when we're thinking specifically about autism, it could be the case that, for instance, maybe it's our loss of function kids have this very strong autism phenotype that's a little bit darker. And maybe some kids that have gain of function variants might have a weaker autism phenotype, maybe some similar traits. And what we're really trying to do in my lab in particular is kind of look at these different levels and look at the brain and try to understand how, if this gene is disrupted, then what does that cascade look like? So how does having synapses that are either maybe hyperactive or hypoactive, how does that change the way that we think and process the world around us? So I'll spend time talking about particularly this level of information processing, and the kind of best tool that we have to understand about information processing is EEG. So I'm going to spend just a couple minutes here just talking about what EEG is and why I think it's so cool and why I get really fired up to do this work in homes. So the way that the brain works, we have all of these neurons in our brains. We've got neurons all over our body, but when we're using our brains to kind of process information and understand things, or maybe listen to sounds in the world, you see these kind of like activation patterns. And we can measure this with MRIs, right? So this is, they're very expensive. There's a lot of kind of stimulation from being in a small tube. They're noisy. It can be really tough, particularly for our kiddos to kind of get through that. So another way of kind of trying to understand and look at these patterns of brain activation, the other piece that happens when you're using these neurons is that they send out these electrical signals, and they actually go in two different directions. So you've got the negative changes in electricity kind of go one way, and the positive changes in electricity go the other way. We call this a dipole. And so what we can do is on the scalp, we actually put on these, we call them high density nets. So each of these little circles here is a different recording site. And we're able to kind of look at the electrical signal at each of these different locations. And that tells us about how the brain is working in that moment. So we're picking up on all sorts of electricity. So importantly, the brain, but your muscles also have a lot of changes. We would pick up on seizure activity. We also can pick up on electricity in the room. So there's some considerations and some things that we do to really like hone in on brain responses specifically. So for those of you who haven't seen, our baby videos are always the high point. So our nets go on very quickly. This is partly why we use this style. And usually even for kids that have heightened sensory sensitivities, usually by the time it's on, we have one person who's just kind of doing some distractions, and kids can actually kind of forget about this net being on their head, even though it's kind of wet and weird. And then we can jump right into testing. So we use what we call high density systems. So here's a couple of different montage options. So we use this one here on the far right because it has that many more channels. So you can see like a couple of these channels are not currently flipped to the skin. If a kid is, maybe has an issue with the electrodes on the ear, we have other ones that we can use for measurements. So it ends up being very flexible, so it's more data than we need and gives us some options if there's some data quality concerns. So what we're actually measuring with the EEG, it really is just how the electricity changes, and it gets, positive and negative, and it's just fluctuating kind of around a stable point. And so what we can do is we can take big chunks of this raw EEG signal. So maybe this is, 2 minutes of just watching a person open presents. And then this is 2 minutes of a toy spinning around by itself. And so we can kind of compare and contrast how that change in electricity is different between those two different conditions. One way we can look at what we call spectral analyses, and this is really related to kind of the frequency of these oscillations. So these low and slow delta waves are really part of kind of like the autonomic regulatory mechanisms of your body. When you get into alpha signals here, it's more about kind of cognition and how you're making sense of the world. And then we can kind of compare how those two different conditions might look. The other thing that we can do is use what we call event-related potentials, where we really looking at like within a couple of a millisecond. So within even half a second, we're looking to see how the brain is processing that information. So we time lock it or event lock it to when something occurs. This might be showing a face. With SCN2A, we do a lot of auditory tasks. So this might be hearing a sound. And we can look at how that electricity changes over time. And what's really, really cool about this, particularly for our kiddos, is that each of these different peaks and valleys actually are a different stage of cognition. So we're able to kind of look at either how long it takes to get to that peak where it turns over again, as well as how big that response is. And each of those are going to map onto a different part of how the brain is making sense of the world, because we have to detect things and then we start to figure out what that might mean. And then we build predictions based upon that. So it's a really cool way of kind of understanding, at what level and what systems might be different in SCN2A. So when it comes to developing these biomarkers, a lot of our work kind of started with these kind of big lumps. So we'll bring in neurotypical individuals, and then we would bring in this big bucket of children with autism. And we've done a lot of work we'll sequence the blood, and there's a lot of kids with autism. We don't necessarily know what the genetic root of their autism is. So we've called those in this diagram here non-genetically guided autism. But then we can also look at kiddos that have likely gene disrupting mutations. And because we're doing this genetics first approach, not all of them have autism, but we're really looking to see what those patterns look like. So one of our, I think, most promising biomarkers is this auditory attention biomarker. And we see different patterns in these different gene groups like CHD8 and DYRK1A and GRIN2B. And in SCN2A, we had this really interesting pattern where there's this, and it's very big. I didn't put the scale on here, but this scale it's a very big response in SCN2A. And it might be, we call it excessive in the sense that your brain shouldn't be processing these sounds or working that hard to process these sounds. So it might interfere with our kiddos' abilities to kind of shift attention in other ways. So a lot of this work is really about kind of seeing as many kids as possible. Each of this prelim data is from 7 kids in each of the different groups. And we have, I think, over 100 of idiopathic or these non-families currently. So we're really starting to work on understanding how SCN2A is specifically different than other gene groups, as well as autism in this idiopathic sense. And then hopefully we'll start digging into specific variants of SCN2A. So to get all of this rich data, we are actually in the process of launching our road trip. So this is being funded by the Families SCN2A Foundation, as well as the GRIN2B Foundation. So we're seeing kids with SCN2A or GRIN2B disruptive mutations. And technically this started last week. But we launch in earnest later this week as well. So we bring our equipment, and it ends up being in those 2 suitcases in that last slide. Is all the equipment we have. I have this paddleboard here for scale. So we haul these, and it's expensive and heavy, but it's easy to roll it into your house, and we can set it up in a lot of different ways. So we'll spend about an hour or so kind of putting the equipment together, making sure that everything's connected correctly. And then we'll bring the kiddo in to do our EEG session. And it's worked fantastically well, particularly in home environments. It's where kids are comfortable, and it's weird and it's unusual, and we try to make it a fun experience. But it's really helpful that our kiddos don't have to travel and that we can come to them. Some scientific challenges are the fact that we don't have as much control over the environment. So I have a little reader that kind of shows me where other sources of electricity are. It's actually what they use in all those ghost hunter shows. And it requires, a really well trained RA. I think I've pretty much done all of our mobile testings because there's a lot of technical pieces. If you're missing a cord or if you forgot to click a button, it could be kind of a challenge. And then it does take a fair amount to kind of set up, but we actually got it down to, I think, under a half an hour. So here's a couple of different other examples. Like you can see, we pretty much set up wherever is maybe the quietest part in the house. So here's a setup in a bedroom. You can tell I repurposed, I grabbed chairs and table tops. I use, I think this is a diaper box here that the laptop's sitting on. So we figure out a way to make it work with whatever your space is. So the first couple minutes are usually me kind of walking around, looking at what we think might work. We're actually also developing a strategy for testing outside. So we'd like everything to be covered. So we have the pop-up canopy that we can bring. Or we can also test, we can try, I haven't actually gotten a chance to test this out, but try with testing in the garage with the door open. So considering COVID, this is something we're planning on implementing this trip for families that are a little bit more are nervous about me being in the house. So some other kind of pieces, this is just a little bit of showing me practicing taking and setting the equipment up. I was actually curious to see how quickly I could do it. And so, we do this quite often. Everything has a spot. So we spend some time getting everything ready. But sometimes there's some challenges. The computers don't always work the way we want them to work. So we try to keep that in mind as well. So before the visit, we spend some time talking with families about kind of what we might expect in their house, and kind of thinking through and having at least a first step plan for where we want to set up. And I'll spend a little bit of time usually like taking away like the really highly distracting things, so that kiddos are focusing on our videos. And then we have, very intensive disinfecting procedures. We actually use hospital grade germicide for the nets. Pretty much after every single session, I'm using laundry either at the hotel or a local laundromat to clean our towels. And we have enough for about a week or so, and then it's time to do some laundry. So we're actually working on streamlining our procedures because we want other people to use these skills as well. So my graduate student at Alabama, Nicole Friedman, and Brianna Carney, who was part of the Tiger study, for anyone who might have got to meet Bree through the Tiger study, are working with me on putting these materials on our website and really talking through how to use them so other scientists can hopefully do the same thing. So we spent a lot of time building this plan and talking with the parents about what might be helpful for your child. So I pulled a couple of just questions that I'll go through pretty quickly, just to give you an idea of some of the things that we think about for, what communication strategies look like, how active your child might be, and how they react to kind of new people and environments. Understanding like, well, what does it take to get them to sit still? And we've got flexibility. We can pause experiments. We can unplug and like go to the bathroom or go get a snack. Like we have lots of opportunities. So if it's 5 minutes is really the max, then that's okay. Maybe we'll do 5 minutes and take a break and come back. Understanding their sensory sensitivities can be really important as well, and what reinforcement strategies work. I'm happy to give an M&M every minute, for example. So whatever tends to kind of work for your child is what we're looking to do, because we want them to sit as still as possible and be as attentive as possible. Sometimes people fall asleep, and that's also actually okay as well. Yeah, so just some kind of examples of really trying to understand what kiddos need to kind of be their best. We also have social stories that we can develop. We've actually developed some for specific kids that might have like a particular restricted interest. I think what our favorite one, we made a Batman story for a kiddo that wanted to wear a Batman hat all the time. So the Batman hat had to come off. So we built a special social story about how to do brain science. You have to be Bruce Wayne. And that means taking off the bat costume. And the kiddo got really excited and had a great time. So some other kind of strategies, we have this kind of like low budget option for practicing, which is just to wear a wig cap. So we can send this home and give you some kind of tricks to use. If you're particularly worried about like the cords and the wetness, we also have kind of manufactured this more advanced version of the wig cap where we sew on buttons and have pom-poms and strings that we hang. And we actually have this kind of stepwise version of what that looks like, as well as a video that you and your kiddo can watch ahead of time. So and here is our very favorite warrior of mine. This is Ben, actually doing some of the testing. I think this is his very first time. I keep meaning to add to this because this is kind of like Ben's, the moments of transition where it was clear that he was needing something different. So you can see he started to kick his feet. And so we switched to having him, giving him something else to look at, which he wasn't really interested in, which is okay. So we switched positions to kind of offer some comfort. And then I think at some point, one of the researchers also just kind of hung out with Ben. So, and he got great data from the session. This is why I say I need to redo this video, because there were so many other moments. It was just these pieces were kind of cues to us that we needed to try something else or give him a break, which is kind of what we're looking for in those kind of pre-phone calls, but also just to showcase the fact that we can be very flexible in the moment. So we'll do all that we can to kind of prepare, and we have extensive training that we undergo with all of our kiddos. Oops. And this is another video. This is actually from the SCN2A conference last year to show you what the data actually looks like. So this is all of those different channels, and you can see ongoing changes in brain activity. And this little kiddo is actually, sucking a pacifier, which was what we needed to do. And it didn't disrupt the signal. Okay. I don't know if you can hear. Can you guys hear the sounds in that? Let's go back here. Okay. All right. So I probably have gone way too far. I'm sorry, I got just excited to just chat. So if you're interested in learning more about this study in particular, you can find more information here on our BioGene study page, or just send me an email and I'm happy to set up a time to talk. So we're currently scheduling and planning on seeing families within the continental US. And we're really hoping that once COVID is a little bit better under control, that next fall or the following spring, we'll actually go into out of just the continental US. We have a lot of families in Canada that are interested. I really want to get to Europe to meet with those families. And then we're really trying to kind of lean into other genes as well. So this is, we're hoping to kind of be more involved in the GRIN community and SETBP1 community. So there's other gene groups that are interested in understanding how biomarkers for their events. And that's so important because that helps us understand what's unique for SCN2A and what might be shared across different gene groups. So here's kind of an overview of what this is going to look like, a little bit of, and some kind of approximate dates that this needs to be updated. But even if you don't see your kind of location on here and you're interested and want to learn more about that, I have some flexibility around most of these days, and we can either add you in or schedule you for maybe in the early spring. We're just really excited to see as many families as possible. So just to kind of like wrap up really quickly, like this is really kind of our goal. So we're here in the biogene kind of looking at this information processing level. And we're really excited about some of the new up and coming grants that the Families SCN2A Foundation was able to award this year that are going to look at some of these other kind of levels. And then we also are connecting back up to some of these other studies. I came from the UW Tiger study, so I still work very closely with them, as well as Dr. Ann Berg's CTRS study and Simon Searchlight. So really the goal is to connect all of our things together. And we're hoping that by developing these biomarkers in the brain, we'll be able to use those to understand the outcomes from clinical trials. All right, so I'm sorry that I went over. I should have timed myself better. The one last thing I should just mention is that I'm actually changing universities. So this year I'll be at the University of Alabama, but in the fall of 2022, I'm moving to the University of South Carolina. And I'm really excited about some of the opportunities there to really lean into this work in particular, because there are a lot of molecular and cellular neuroscientists that are very, very interested in SCN2A specifically. So I'm really excited for kind of using this action potential grant and really being able to catalyze that and jump into some neat studies with other professionals in the near future. So I'll go ahead and stop screen share and see if there's any questions.
Feel free to use the reactions button on the bottom to raise your hand if you have a question, or we have a small group, so you can just unmute and ask a question. I do have a few that came through the Facebook group that I can ask, but I just wanted to give everyone an opportunity first. Okay, well, maybe this will break the ice a little bit. Caitlin, that's so cool. Like, and I almost forgot, like Ben was that little at one point. That was so cute to watch. Can you tell us a little bit more about what a biomarker is and what that means, and why it's important and to who it's important to? Like, is it important to researchers or industry groups, pharma groups? And why this is such a critical project?
So the reason, so let's start. Yeah, and I probably should have slowed down there. Thank you for that question. So a biomarker is any sort of biological indicator of a disease or a disorder. And some other kind of diseases like head injuries and concussion, they're really working to synthesize things in the blood. Like, could we do a blood draw and then know if a condition is present? And this is important because we want to be able to know when the condition is resolved, right? And having, fewer problems. And, for SCN2A, like the goal is really to understand and improve how kiddos are understanding the world around them. And that's what we can measure with these EEG brain biomarkers. I don't think it's the only biomarker that's going to be important, but it's a really unique way of connecting between what we see in terms of behaviors, the strengths that kids might be developing, clearly the things that really matter in terms of function, like are some basic life skills, and you don't necessarily need a brain biomarker to navigate those successes. But what we're trying to understand is particularly given how much we know about SCN2A as a gene and its role and its functional significance. So we actually can be mapping at the brain level how, like, those downstream consequences. So if we're able to either pharmacologically come in and build compensatory mechanisms for the disrupted gene, or produce additional proteins that might compensate for the gene function, that's going to have these other downstream effects on how the brain is able to make sense of the world. And that's what we're trying to measure. So we see this as a preclinical trial study, because it's hard to make some of these make sense of those results with just so few kids. So I think by the end of the BioGene kind of period, I think by early spring, we'll have over 30 kids with SCN2A having done some brain, one of our studies, either through Tiger or through the BioGene study. And that's really what we need to have, like a first pass candidate biomarker that the drug companies are going to look for. So for example, in autism, there are currently undergoing FDA approval for one particular event-related potential called the N170. So this is the response to faces in particular. And there's a couple different groups that have put together a proposal, and it's gone to the FDA for clearance. And it's going to take a little bit more time because this is a rare population, but that's kind of the strategy of what we're trying to look at. But we're also aware of the fact that, there's a lot of kids with SCN2A that are not going to be presenting with the autism phenotype. And so those brain signatures are going to look really different. And it's important to kind of know what might be shared between gain of function or loss of function variants and what the gene is actually doing as kind of like an SCN2A like general biomarker, or if we need to develop these specific ones for each variant potentially. And one more thing I'll say, because I'm really excited about the South Carolina shift, is that we're also really interested in working with iPSCs, so induced pluripotent stem cells, because we can actually then look at specific variants and look to see how those neurons develop and grow and respond, and how that maps onto how our brain biomarkers are showcasing those same kind of skills.
You'll be able to study the same thing in the cell lines, in the iPSCs?
So hopefully this is still a work in progress, but I'm very excited about just being with neuroscientists that really want to they have the technology and are interested in this question specifically.
Yeah. Well, you answered the other question that I had, which was how does it look different in gain of function versus loss of function, or epilepsy versus no epilepsy? Have you seen any difference yet in those two groups?
So we don't have as many kids with gain of function variants. We have a lot of kids with either variants of unknown significance, which are oftentimes not included in research questions because it's just hard to know whether that specific variant caused it. So we have a bunch of kids that have these maybe more complex variants that haven't been fully characterized in kind of the wet lab kind of scenario. And so we've kind of focused at first on those that are pathogenic. But that's what I'm really looking forward to, I think in the next month or two. So if you want to have me back in a couple of months, I think we'll have some new data and that'll be able to address that. I do anticipate that they're going to be very different from just a few kids that we've seen, but it's hard to know what is kind of a unique individual signature and what is. So like statistically, we just need a couple more kids before we can confirm that.
Renee, I noticed that you put a comment in here that you'd like to participate, and you are in Little Rock. Did you want to take yourself off mute and ask Caitlin any questions directly?
Yeah, actually, I just unmuted to ask a question. So that's perfect. We are a gain of function. I have an 18-year-old and very recently diagnosed. We've done genetic testing several times through his lifetime and just never caught anything. And they kept saying, try it again, we'll try it again, we'll try it again. And finally did within the last year and caught that. And we have an insertion error on the SC2A gene and we fit, once I started reading and learning a little bit more about this diagnosis, I was like, where's this been all of our lives, it just really made sense. And so we're in Little Rock, and I did see your map that shows you would be in Little Rock in November. And we would be really interested in participating. That's something that, we're kind of trying to pull together things and we got a diagnosis in July and seen genetics on neuro today for the first time since our diagnosis, which was interesting. And so that is something we really would like to visit about. And if I could get your email, I'd be happy to shoot you an email with a little bit more and all that in one in one place.
Yeah, so I'll put my email here in the chat.
Perfect.
But for anyone who's not, are there people on Facebook Live maybe too? It's cmhudac@ua.edu. And I think if you kind of put in like SCN2A, biomarker, EEG, I bet you I'll pop up too. So, and I think we're listed on the SCN2A research page there as well. So, yeah, I'm very excited to meet you, Renee, and we'll be in touch about what that would look like.
That would be perfect. Thank you.
Of course.
Thanks, Renee. I see a question from Carla here, and I happen to know Carla needs to stay on mute, so I'll ask it. Is there an age range to participate?
Great. Yes. So I'm seeing kids of all ages. We can see adults as well. Most of the participants that we have been, I'd say, under the age of 25, but we've seen babies all the way through adulthood. I think I have like I don't know that I can see anyone over the age of 90, but that's I think a pretty big range.
Awesome, thank you.
And one of the things that you kind of mentioned, Leah, that I want to just kind of mention. So we're a developmental lab. So one of the things that's really important to me is that this isn't just a one-off. Like, I really want us to understand how different therapies and treatments might be helpful in changing for kiddos. So we're really hoping, particularly with the move to South Carolina, that we start seeing kiddos regularly. So maybe each year kind of, and so it's going to be great when we're all back in person at the conference, but we'll also probably maybe have these road trips a lot more frequently. It might not always be me on the road, but so if you've already been seen through like the Tiger study, but you're interested in having like a follow-up, you can also participate in the BioGene study again.
Caitlin, is there any pre-work that they have to do, like any forms to fill out or surveys? And what is the ask of that?
Yes, that's a great question. I'm trying to get everything online. It's been a little tricky. It's kind of like a one-woman operation right now, and scheduling is not my strength. So I appreciate everyone's patience. I'd like to talk to everyone for a little bit before each visit. So those kind of questions I mentioned will just help me prepare and have whatever little tricks or toys or candy or whatever we need to make the session successful. If you've already done Tiger, we have a memorandum of understanding. So there's a lot of things that you might not necessarily have to do, but we might ask some follow-up questions about like the medical history, just to kind of see if there have been any updates or changes. And then there are a couple of parent forms that, so we did a family last week, and in the 30 to 40 minutes it took me to set up the equipment, and I was hanging out with kiddo at the same time. Mom was able to complete them in about that time frame, but I'll also hopefully have these online and be able to send them to you ahead of time, so that you can kind of do those forms at your leisure. And it can be frustrating. Like I've limited them to the things that I think are really going to be important. Some of the questions are going to be like frustrating, like your kid might not necessarily have some of the skills we're asking about, but it's important for us to kind of know for standardization reasons. And if you fill them out for instance, for Dr. Berg's study or Simon's, we're trying to work with both of the other studies to kind of have better sharing of data, but that might be a little bit far away. And it's helpful for us to kind of know, like, well, what is current behaviors to map that onto the current brain responses that we're getting. So we know that some of this is redundant. We're working on that. And Berg and I had a great conversation last week about really moving in a direction so that there's not this redundancy. So that's kind of like a little apology in advance. Like we know your time is precious. And then I guess just to say the session with the kiddos is going to be 30 minutes at the most from when they put the net on. Now, if they need to take a lot of breaks in between, we will. So it might be a little bit longer, but I think it's more likely that kids are going to be out of the chair within 20 to 30 minutes.
And you know, honestly, the SCN2A group, the families in our group, they're so willing to participate and they're so good about filling these out. We know that it's a pain. We know we hate answering the Vineland question 19 times a year. Believe me, we do. But we also realize that it's really important and that everything we're doing is pioneering a path forward for the next generation. So things for minimizing the duplication of efforts, but I think that we're good. Carla's just spouting off questions in here. She wants to know if you've thought of having a CVI trained vision therapist to help with visual stimulation. And I can almost think that you could do that just in a consult with them, you know, some techniques that you can use, because we do have quite a few kids with cortical visual impairment.
Yeah, I talked with a good colleague of mine, Dr. Fred Schick, who's an eye tracking expert. So we talked about this a little bit more extensively yesterday, actually, and that's something we're working on. So we've kind of leaned into at least starting with auditory biomarkers because it just evens the playing field for kids that have different visual attention needs. But it's clear to me that something's going on there. And so we're working on trying to figure out how best to understand, first of all, like what's going on with all of the cortical visual impairment. But then also to think through like exactly what you're suggesting, Carla, like how can we actually use each kiddo's kind of unique visual kind of draws and use those as kind of motivating factors. So it's less relevant for this study because there's only one experiment that we're doing that involves visual attention. And we usually kind of cut it just in the interest of time, but we're working on that hopefully soon.
Thank you. And just to note, sometimes kids with cortical visual impairment, this is something I've learned from my son's teacher for the visually impaired, asking him to use his auditory, we do have to regulate his visual stimulation as well. So it might not hurt to think about it when you're setting it up for a kiddo that does have CVI, like, you know, are they facing a window or they might be light stimming on that, and then that might interfere with their ability to use their auditory. I don't know. I'm just guessing here on what Carla put on here. And I think you did answer, if you've already participated in Tiger, this round you prefer to do first timers, is that right?
I'm hoping to see first timers, but it's if I can fit in families for second or other times, I'm considering it if there's just a couple of days where I have more flexibility. So you can reach out to me if you've already done Tiger and are interested in doing a second session, and I can let you know if it'll work, just because we definitely want to see all the first timers. They're just taking priority first, but you know, and I've kind of like gone back and forth on this a little bit because I'm there, and if I'm coming by your neighborhood, then I would really like to be able to kind of see families and really have a couple more kids that have multiple time points so we can look at some of these developmental pieces. I'll come over, Carla.
Yeah, you might need to, because she just keeps asking questions. No, good. Keep it up, Carla. Does anybody else have any questions for Caitlin?
Well, so Carla asked about if they register with CRID, can we connect to CRID? And I actually don't know that I know that acronym.
So that's a new thing that just came out, and it's with it's Combined Brain and Jerry Nesbitt actually worked together to create this. It's a clinical research identifier, so it's like a unique identifier, but we can connect it with any research that we're participating in. So of course you'll have a unique identifier for each patient that's participating in Biogene, but then we can connect our CRID to it. So then the CRID can pull all of it together in one place. It's an attempt at reducing data silos.
That's great. And I will, now that I know that it exists, I'll look into it because that sounds fantastic.
Thank you. Oh, Carla says she's clapping her hands. I think I did have another question. Somebody wants to know if when they have the EEG on, can it pick up epileptic activity?
That's a great question. So I'm a developmental psychologist. I am not a neurologist. And so there's certain kind of clinical reads that are just not going to be things that we can do within the study. Now that said, whenever, you know, you are currently experiencing a seizure, it does look a little different. So we're working to pair more closely with medical clinicians to understand that. The only other piece of it is that because it's a research-based kind of scan, it actually does look a little bit different in terms of how we set up the hardware and the software. So there's certain like filters and things that get applied to clean the data that in some ways actually smooth over things that might be seizure activity. So it's certainly not a replacement for any sort of clinical test. And we're very clearly like research only, like we're not in a position to offer any sort of incidental findings or anything like that. But it's something that we want that partnership because it's important. And if it's a matter of kind of, you know, and it could be really nice to kind of turn off our filters and kind of work on maybe also having like a minute or two of non-research acquisition. We just don't currently know what we would do with it. So it hasn't been as much of a priority, but I think that it's no surprise that I love working with the Families SCN2A Foundation because of how much partnership there is between families and researchers. So if that's something that the family group really thinks should be a priority, I'd be happy to kind of look more into that.
Thank you. You're so easy to work with. It's such a joy to work with you. That is a great answer. And Carla wants to know if there's any kind of copy that you give to patients.
No, we haven't in the past. I actually don't know that a neurologist would know how to open and read our file types. But if that's something you want, like I think on a case-by-case basis, I can touch base and maybe if you share your neurologist information, we can kind of look to see if that's something that they actually would be interested in, or if they have things that they might want me to specifically look for, or yeah, so we can check about that. We haven't done it in the past, so it's certainly not something that we do often, but you know, it is your child's data, and I, you know, it's not a territory thing. It's just a practical hurdle that we haven't quite thought through.
No problem. Thank you. Emily, you have your hand up.
Hi, I have a question. So I guess you're reading on the EEG different responses to auditory. How about for visual, such as, I know a lot of our kids have CVI, and I know that they're drawn to very specific colors and they respond a lot, like very strongly to red or orange or yellow, versus say like gray or green. Are you also taking a look at that?
So we don't currently have like an experiment specifically to tackle that, in part because we've had so much success with the auditory biomarkers. Like, I feel like it's the cleanest data that we've ever gotten, which is really good, because it can be problematic if kids are moving and touching the net. And when it comes to visual experiments, our SCN2A kiddos just really don't look at the screen in the same way, right? So even like regardless of what content's on there, and I think that you have a very interesting point about like the content of the visual thing, information could be really important. But we have a lot of kids that'll, do the side looks, and when you start to move head positions and look at the visual brain signals, it actually really matters the orientation of your eyes to the screen. So, so Dr. Schick and I were talking last night about, well, like, what can you do for kids that, don't look? And he actually had a lot of really great ideas for using eye tracking more than EEG. So, because I was thinking that it would be really tough for kids that are not looking at the camera or the screen as a straight on kind of angle. And he's like, oh no, we can work with that. So we're hopefully, I think the kind of the way that we would develop a experiment around this is probably having something that we call visual search arrays. And so we would basically put on the screen a bunch of different objects, and they might vary in different colors. And we can look to see, do they only fixate like on the red sparkly object, or are they drawn to a particular kind of motion? Like if it's like a GIF or a GIF and it's, moving around in a circle, is that something that's more compelling than maybe like a flash? So I think that there's actually some really interesting ways that we could use eye tracking to understand what is drawing in the attention, because I don't know that we have that answer yet. So I think it'd be really fun to do that.
Yeah, from a parent or from just a very functional standpoint, I would say during, like, all of our kids have OT, and even in a classroom setting, it would be very interesting because visual is such a large component to their learning.
Yes.
And I'm just curious if that could be studied, or if you're seeing anything, or if you might even see things pop up sporadically so far as their visual. And to go back to Carla's question is about the addition of a CVI trained vision therapist. To kind of guide, or even if there's a questionnaire that the parents fill out, if there is something, like, what does your child look at? Like, if anything,
Yeah.
Or I'm just wondering if there's something that could be preliminarily fielded, at least this time around. I mean, I have absolutely no idea how to run these kinds of, I don't know how to gather data like you do, but yeah, I think I was just thinking a lot about that visual component.
And I think that it's a great point, Emily. Like, and I immediately was like, well, how do we build an experiment for it? But you're right. The first piece is just kind of doing some basic data collection and surveying parents. And that's something that we could possibly do. And maybe I'll work that into just some of our interviews that we do. Like, I think it could be really important to know that. So I'll think on, and maybe what I can do is maybe if there's a small number of people that would be interested in just kind of even helping me develop what questions are going to be important to ask or how to ask them. And because you guys see your kiddos and what they're looking at every day. So I'd love to work with some people to develop something to use this opportunity momentum to address some of that.
Yeah, for sure. It's funny, we can't get our kids to look at their lessons when they need to, but I know that it's my daughter and Ben, it's the same. If there's a veggie stick across the room in an obscure location, they'll spot it in an instant and they will look at it.
Don't drop a veggie straw around them.
Oh, but I love hearing this. I think I saw, Carla, you asked about getting images ahead of time to practice. And that's an interesting question, because a lot of times we're trying to get the brain response to the first time they see things. So it would have to depend on, like we want to know, like when they see something brand new, what directs their attention. But we could potentially work in, maybe we send some that are practiced ahead of time and some that aren't, but we'd have to think about that a little bit. Because it actually could be, a really helpful piece to know, like what's going to work for kind of clinical trials to, can we measure this spontaneously, or do we really need to have kind of a setup, multiple kind of sessions to practice ahead of doing maybe more advanced scientific things?
Caitlin, I know that you went into detail about this already, and I hope you don't mind if I just bring it up again, but just to clarify to the general community here, biomarkers are something, let's say that there's a clinical trial for a certain therapeutic. You do this before it, then you give them the therapeutic, and then you do it after, and you expect to see a change, correct?
Correct.
We're measuring. So in your opinion, you see this being something that could be validated by the FDA to use in clinical trials in the future?
Yes, and the part that I'm excited about is with EEG, unlike other measures, like the Vineland, you get like 1 score, and that's maybe changing, or maybe it's not. Some of these Vineland questions are maybe not going to be what's changing, but with the brain, it's much more subtle. And because we can pull apart those different cognitive stages with the different peaks and troughs, then it actually tells us a little bit more about how the information is being managed and processed. So for instance, this auditory biomarker that is the one I'm pushing on for this current round, we can look and see, is it that the initial detection of the sound is just what is maybe not working the same way. So when you hear a sound that gets repeated over and over and over again, then that becomes less important. So when you hear the new information, your brain should have a bigger response. So we can look to see, well, is your brain, detecting it correctly? And then we can say, well, what do you do with that information? So once you know that something is different, that your auditory part of your brain is just processing the sound correctly, then what do you do with it? How do you extract out that meaning? And so that was the kind of red and black lines that I showed with some of the other gene groups. In SCN2A, we're seeing this as a much bigger response. And that's like our kind of late stage cognitive response. So they're detecting it and understanding that it should be different in the world. They can extract some of that meaning, but our kiddos with SCN2A are overly responsive to these new sounds. And that doesn't go away. And they continue to be like heightened and aware of these sounds, which can be a problem because then you're not able to kind of filter out some of the other information in the world. And so it's this idea of being able to then say that, from a clinical trial perspective, that this trial, whatever it may be, was effective in reducing down that over responsiveness. And it gives us a better pinpoint of what actually changed. And maybe that also then relates to adaptive behaviors or communication abilities. And we're hoping to see that, but that's at such a gross level that when we're looking at the brain, we have these nuances that we can actually like target and understand, kind of like from a computer perspective, you know, what are the inputs and what shifted. I'm not always good at analogies,
So
but
that was fantastic, and it's such good timing for our community because we are looking forward to clinical trials in the next couple of years. So this will be super important. So participation in this is really critical. Thank you for explaining that. Does anyone have any other questions? Caitlin, I was wondering if you could share with me, so I can share it in our community, your map, and make sure that we can't try to get a couple more people in some of the areas that you do have room, because they might just not know about it, and sometimes we have to post an email and whatnot.
so I'm going to keep my webpage up to date. I think I put the map on my web page, which I could grab the link and put that on here as well. And I'm happy to share that with you, Leah, to pass around. I think it's actually changed since I posted this initially. So for instance, Renee, I think I might be in Arkansas at a different time than what was on the calendar, but and I was trying to think about like how best to kind of keep track. So I might actually start writing a little blog so people can like just see like where I'm headed, and I'll be very careful. I'm not gonna like report on like what towns I'm actually testing people in, but I'll kind of share what general kind of part of the world I am, because I respect everyone's confidentiality, but that way you can know if I'm coming to your state, maybe more broadly. And I was actually I was thinking that it was going to be 3 hours of a visit, and I got it down to 2, and that was the first one. So I think that it's only going to go and be kind of in a nice pace. So having those conversations ahead of time will just help me know kind of where we're going to set up and what that's going to look like. And so I think that actually we can fit more families in, and I'm motivated to do so. Like it's a lot to do this trip, but I'm here for it. So just keep me posted on how I can help, and if I miss a family, then we'll come back. Like this isn't like the end of the line. This is just our big push.
Yeah. And in 2022, we are hoping to have a conference in Columbus, Ohio, and you'll be there. So
yes,
that'll work out. Thank you so much for your time. I think we're done with questions, Emily. I don't see anybody else's hands up.
Yes, that was an amazing session. Thank you so much, Caitlin, for volunteering your time to help us understand this exciting work better. Thank you to the families who joined us today. Your questions and comments were very insightful. If you are like me, you will think of questions later as you digest the science. As always, the volunteers and staff at the Families SCN2A Foundation are here for you, and you can send us questions anytime. We'll do our best to get them answered for you. There are 3 more table talks in the RX Hope virtual series. Be sure to register for them in advance. We'll make the recordings available as soon as possible. There's so much work still left to do, and we could use your help. A major way to get involved right now is through the SCN2A Clinical Trial Readiness Study. If you haven't registered yet, do so right now at scn2a.study. Links are on our website and will be in the last 20 seconds of this recording. Thank you.